Hello. In this video, I'm going to discuss how to deal with the different types of inventory according to an ABC classification. In inventory management, as in many other contexts, we have what is called an ABC classification or a Pareto curve. The phenomenon is the following. For example, in a different context, you can find that when a company has a set of customers, typically there are a few of those that account for most of the income. Or if you have, for example, failures of a machine, of all the types of failure, there are a few of those that account for most of the costs derived from what happens when you have failures. The same happens with inventory. You have some items which are called IA items that, although they are few compared to the rest of the items we have, they account for most of the value we have. And at the other end, we have what we call C items, which, although they are large in number, they are low in volume. So we have some orientative figures here. We can have 5 to 15% of our items that, in terms of their value, represent 50 to 60%. At the other end, as I said, I have C items, which account for most of the room, if they were supposed to have pretty much the same size of our warehouse. In number, they are somewhere between 55 or 75, but they only represent up to a quarter of the total value. And somewhere in between, we have the items that are nor that low value items, but they do not represent neither a large amount nor a small one. So it could represent it in terms of a plot like this. If we have the horizontal axis where you have the number of items and the value, now this a little number of items that account for a large value in terms of what they represent compared to the total value. And we have C items which are large in number, but they only account for this value of the total value we have in our warehouse. Let's see a very simple example. Let's imagine a company that has this set of reference, only 10, and we have an annual volume. This could be the total items that we have over a whole year, or this could be the average inventory, something that represents how many items we have to deal with of each of these references. And we have the unit cost, which is difference across different items. Okay, so we have some items which are large in number, like this one here, of which we have 2,000, and we have others of which we have just a few, which is the case here, 100. But we can extend this calculation and build the following table. We still have here the reference, and we have these two columns, the annual volume and the unitary cost, which we already have. What we have here is a new column, which is the percentage of volume. Okay, so this 11.7% is 1,000 divided by the total amount of items I have, which is 8,550, the summation of these whole, and the same for the rest of the references. Okay, and we have now some more new columns here, which is the annual value in terms of what they represent according to their cost. So this 94,000 is 94, the unit cost of that item, times 1,000, which is the annual volume we have measured in units. And the same for the rest of all our items. And notice that these are already sorted in descending order, so that this item we have here is the one with a higher annual volume, and here we have the one with the lowest annual volume. And we can divide the annual value of each reference by the total value in our inventory. So we have these percentages here. So this 39.2 is 90,000 divided by this 200,000 units. So now we can try to group them in categories like we've done here. We have these two first reference account for 72% of the value, whereas these 5 last ones account for less than 5%. So clearly these are A items and these are C items, and those here are somewhere in between. But these items, if we take a look at how much they represent in terms of the volume measured in units, is less than 20%. So we have a classical Pareto arrangement where we have less than 20% of the items accounting for more than 70% of the value, and almost 50% of our unit volume that accounts for only 5%. So it's clear that we cannot address the same way how to deal with these items here because they are very valuable, and how we treat these items here. Indeed, if we get back to our previous classification, our previous slide, we can think of A items in the aerospace industry. In terms of engines, they are very costly, and we can think of C items when we see rivets, which is the way to bind together parts of a part in an airplane. And we have B items that are not this valuable and are not as common and low valuable like these ones. So they should be treated very differently, and the image invites to think in those terms. So the ways to deal with uncertainty are both passive and active. In terms of passive ways to address uncertainty, what we typically do is to add safety stock to make up for variability in our demand, to make up for the situation where we have larger demand than expected. But in this case, this is not the way to treat our inventory, because we cannot just have plenty of engines just in case we need them. Okay, so in this case, what we want is to have a low service level, which means having a low safety stock. This doesn't mean that we run the risk of running out of stock. It's just that we have a low safety stock as defined in classical policies for inventory management. But to make up for this low safety stock, what we have to do is to have a very tight control over our inventory. So we will have people making sure that orders are delivered on time, that we have the right amount, the right quality, so that it's not that we just place an order and we forget about that. So we have a very tight control. Since the value of our inventory is very high, what we will do is to place orders very frequently and in very low quantities. So we prefer to pay the fixed cost per order many times, so that we don't have much inventory within our warehouse. We prefer to negotiate low lead times with our suppliers, because that way we can also combine that with ordering very frequently and having less uncertainty during the lead time, and being able to run away from stock out situations. And finally, we would like to invest, to put money into having good forecasting methods, okay, because that means reducing the uncertainty of our demand, and that will allow us to have a better estimate of what we will need, and we will have the chance to reduce our safety stock, which is what we want, so that we don't have much money put into this inventory. As with C items, we will do the opposite. We will try to order in high quantities. We are not so much concerned on having our safety stock low, because these are very low value items. So we prefer to buy in large quantities, get discounts in terms of price, and have this managed automatically. We don't want to have people taking care of it in a very detailed manner. And for that, we try to simplify transactions so that it's just business as usual, and we get rivets in this case as needed, and we are not so much concerned about what we want to do with engines. And obviously, for B items, what we want to do is something which lies in between these two situations. We might want to have some kind of forecast, but not so accurate, and not put that much money into them, and having some kind of control, but not as tight as the one we have for B items. So this analysis is very important, because that way we can devote the right effort to the right elements in our inventory, because if we make mistakes in that sense, we will run out of those engines instead of rivets, those engines which are very high valuable for us, and we will have either stockouts, which will cause serious trouble, or we will have a not very efficient operation because we will have too much money put in the way of inventory.